Hi, this is Mr. Nazarian. Our lesson objective today, I can build multiple towers by using what I know about multiples. And we are going to use this to help us as we work on dividing using multiples next time in our next lesson tomorrow. Okay, so this is going, like I said, is going to really help us as we work on division next time. So let's master this so we can use it as a tool. Alright, so multiple towers are basically just looking at multiples of a number and we stack them and create a tower with them. So multiples, as you'll remember, multiple of a number is like, another way to think of it is like counting numbers. So multiples of 2 would be, think of counting by 2, 2, 4, 6, 8, 10, 12, and so on. Multiples of 3 would be counting by 3s, 3, 6, 9, 12, 15, and so on. So you'll notice when I just gave those examples that the first number of multiples is always itself. So we're going to look at multiples of 4 right now. And so the first multiple of 4 would be 4. And then the second multiple of 4 would be, you would just count up another 4. So the second multiple of 4 would be what? It would be 8. And then the third multiple of 4 would be 4 more than that, 12. And you're going to see that all we're doing is just counting up by 4 every time because we're doing multiples of 4, right? 16, and then 20, 24, 28, 32, 36, and we're going to stop at 40. And we know that 40 is which multiple of 4? That's right, it's the 10th multiple of 4. So that means that if we're counting by 4s, the 10th number that we're going to land on is 40, right? So that also tells us that the factor that you would multiply 4 with to get 40 would be 10. If 12 is the third multiple of 4, that means 4 times 3 would be 12. So as we look at these, I want you to think about any patterns that you see. So for example, as we look at the 10th multiple of 40, or excuse me, the 10th multiple of 4 is 40, and then look at the 5th multiple of 4, which is 20, and what do you notice about those two numbers? How are they related in this multiple tower? So the 5th multiple is 20, and the 10th multiple is 40. So what can you say about the relationship of these two multiples of 4? Okay, so hopefully you see that the 10th multiple, 40, is twice as much as the 5th multiple, which is 20. So, and that makes sense, right? Because 10 is twice as much as 5, so the 10th multiple is going to be twice as much as the 5th multiple. So if we can figure out relatively quickly what the 10th multiple of a number is by, as you'll notice here, right, 4, it just has a 0 in the ones place, right, because that 4 got bumped over one place value because of our base 10 system, right, that if it's 10 times larger, that means that number that was in the ones place moves over to the tens place, and now there's nothing in the ones place. So if we can figure that out, the 10th multiple, what that is quickly, then we can also quickly figure out what the 5th multiple is just by cutting this number in half. Now let's look at, are there any other patterns here? For example, 8 is the second multiple. And how about the 4th multiple here is 16. So what relationship do you notice between the second multiple and the 4th multiple? Okay, hopefully you noticed that 16 is twice as much as 8, just like 4 is twice as much as 2, right? So if you can figure out what the second multiple is fairly quickly just by doubling your first number here, then the 4th multiple is going to be twice as much as that. Again, like we talked about, right? Multiplying by 2 is doubles, multiplying by 4 is doubles. So that's something, if we can figure out what the second multiple is pretty quick, we can figure out what the 4th multiple is pretty quick as well. And then what relationship do you notice between the 3rd multiple here, which is 12, and the 6th multiple here, which is 24? So what do you notice between the third multiple of 12, and the sixth multiple of 24. Hopefully you notice that also, again, it's doubled, right? 24 is twice as much as 12, just like 6 is twice as much as 3. And so you can see these patterns here. The same is true for the eighth multiple, right? If we look at the eighth multiple and the fourth multiple here of 16, eighth multiple of 32. 32 is twice as much as 16, just like so. If you can figure out what the fourth multiple is by figuring out what the second multiple is, you can figure out what the eighth multiple is. And then also, if you look at the third multiple and the ninth multiple, you'll notice the relationship here of that the third multiple 12, ninth multiple 36. 36 is 3 times as much as 12, just like 9 is 3 times as much as 3. The only one that doesn't work out quite so nice is the seventh multiple, but even the seventh multiple, if you know what the third and the fourth multiple is, let's see what that is, 12 and 16. What happens if you add 12 and 16? What do you get? You get 28, which is, guess what? The seventh multiple. So just like 3 plus 4 equals 7, the third multiple and the fourth multiple gives you the seventh multiple. So, and this once we have this multiple, we can figure out what the 20th multiple is, what the 15th multiple is, and so forth. So like, for example, and even let's say the 14th multiple or the 17th multiple. So the 17th multiple, let's say, of 4 would be the 10th multiple and the 7th multiple. So, right, because 17 is 10 and 7. So that means if we take the 10th multiple, which is 40, and the 7th multiple, which is 28, then we know that the 17th multiple is 68, correct? So once we have this, we can figure out other multiples relatively quick, and building this multiple tower should be a relatively painless and quick thing to do. So I'm going to let you tackle this one here and build a multiple tower of 6 all the way up to the 10th multiple. So why don't we, let's see here. What I think I'll do is I'm going to ask you, what would first of all, what would the second multiple of 6 be? Okay, it would be 12, right? Because it's just doubling this first multiple. And what would let's go say the fourth multiple, what would that be? Okay, that would be 24, right? Because remember, the fourth multiple is twice as much as the second multiple, so that gives us 24. And how about the fifth multiple? What would that be? And if you can use another way of solving it, obviously you can just count up 6 more from the fourth multiple. But if we were to go straight to the fifth multiple, how could we figure that out? What's one way that we could use to figure that out? Besides just counting up 5 more from the fourth multiple, or 6 more, excuse me, from the fourth multiple. Okay, so one way that we could do it, and there's a few different ways we could do it, if not many, many ways, but one way you could do it is know what the 10th multiple of this is, which would be 60, right? And then chop that in half, so that should be 30, right? Another way that we could do it is just say, what's 6 times 5? That's 30. Or if we figured out what the fourth multiple is, it would just be one more step up, right? To 6 more. Okay, what would what would the 9th multiple be here? Okay, so let's go all the way up here. It would be 54, right? So you could say, well, 9th multiple of 6 is going to be 6 times 9, which is 54. You could say, well, I know that the third multiple is 18, triple that, and that would give you 54, which might be a little bit more difficult in that situation. Or you could just build up your multiple tower, and then again, the 10th one, it'd be 60. And last question is, what would the 14th multiple of 6 be? Okay. All right, so it would be, remember, the 10th multiple and the 4th multiple, which is 24 and 60. So 60 plus 24 would be 84, would be the 14th multiple. Okay, all right, we will work more on that tomorrow. See you then. Bye.